Hello everyone, so this is a review of rate of change and slope. This is for our second part of Unit 2 on parallel and perpendicular lines. So you should have this day 1 packet, and it has these as a PDN. So if you tried these before, so by the end of this unit you'll be able to figure out how to do all of these and figure out the slope of all of these. If you tried it to check your answers, this should be 5 students per year. This one should be around 2.4 to 2.3 meters per second. The slope of this is 4/5, and the slope of this is 13/9. So through this video, we are going to be covering the notes on how to do each one of these. So the first stop is, this is a unit overview of just how to graph and solve everything. If you need it, it is there. It has some step-by-step processes and some written notes that you can keep and use when you are completing any of these practices. And now we're going to go into the notes of just rate of change. Rate of change, it is slope. So slope of a line you'll know as m, as a review from Algebra 1. But rate of change is how are things changing every year. So this is more in context of from tables or graphs that you'll see in real life, because not everything is perfect when you're dealing with prices of items or anything rising or falling. And what we do is we call that rate of change. It's the change within a given set of time. So there's an example here where you take your time and you find out the change in years, and then on top it's how did the cost change. So if you're thinking about it, the time is always X and the price is Y. So to find the rate of change for any given time period, you find the change in the cost, and then you find the change in the years and you divide them. So in the example, you find the rate of change between 86 and 88. So you would plug in the change in cost. So in 88, it's $1.63, and in 86, it's $1.27. So to find the change, we're going to subtract those, and then we're going to find the change in years, which is as simple as 88 minus 86. So when you do the math on that, you get 0.36 over 2, which is a rate of 18 cents per year. In the next one, it's again 89 minus 88, so it's only a 1-year cost. But you'll notice that it starts at 115. Now the cost is 115, and we started at $1.63. So we actually lost 48 cents that year. So this is a negative 0.48 per year. And now we find the last one, which is 2.26 minus 1.15, 91 minus 89. It is 1.11 over 2, 0.555 per year. So the fact that we find them all as per year, now we can compare them. So what time interval had the greatest rate of change? You're looking for the biggest number. So that is from 89 to 91. it changed the most in price then? Was the rate of change ever negative? Yeah, this was the negative. So from 88 to 89, it was negative because the price dropped. So we try to find the rate of change so that we can compare it and we can put it in one unit and compare them for each time interval. If we didn't do that, then we wouldn't know in a 2-year time frame if it's the same rate of change per year as a 1-year time frame. In our next, now we're dealing with slope. And you will recognize this as the 2 R's, rise over run. So all we're doing with this is now we're taking those lines that we're so used to, and we're doing rise over run. So to remember, rise is your movement up and down. Movement up or down. If you're moving up, it's a positive number. If you're moving down, it's negative. And your run is movement to the right. Now, just like if you were reading a book, we read a graph from left to right. So if we're reading this sentence, we move this way. First, choose any 2 points, right? If we're looking at this line, we read it from this way over. So the movement, the run is always to the right. It allows us to make sure that we have that bottom number, that denominator, as always positive. So the examples for this, I highlighted some of the points. You could choose any 2 points on this. To make it easier for you, I indicated the 2 points so that we can start from a common place. And all you would do is count. So from one point to another, how many boxes did I go up? So I would count 1, 2, 3, 4, 1, 2. So this is my rise. This is my run. So 4 over 2. I would then simplify that to just 2. Because 4 divided by 2 is 2. In my next one, you'll notice I go down first. So down 2 is a negative, but then I go right. 1, 2, 3, 4, 5, 6, 7, 8. That number is always positive. If I go right, negative 2 over 8. I now can reduce that to negative 1 over 4. Same thing here. 1, 2, 3. Now I'm going up 3. 1, 2, 3, 4. I got 3 over 4. I can't simplify it at that point, so I'm done. The trick is slope is a fraction, so it is okay to leave it in fraction form. You just need to simplify it. For this one, you'll notice that the line is falling. It's going down as I go. So I immediately know my slope is going to be negative. So I start counting from here. 1, 2, 3. 1, 2, 3, 4, 5, 6. So down 3 over 6. Down 3 over 6 turns into negative 1/2. These are my 2 points. I now am seeing that it's rising, going up as I go more right. So it's going to be a positive slope. 1, 2, 3. 1, 2, 3. 3 over 3 simplifies to 1. And this one is a very steep negative slope because it's falling. So I would start counting 1, 2, 3, 4, 5 over 1. So negative 5 over 1, which is just negative 5. So if I'm given a graph, I just count the rise over run. So for the next 2 papers, these are your practice problems. And again, it's identifying your rise and run, and then identifying your slope. So please complete those to the best of your ability and ask questions. On the next page, we talk about the slope formula. The slope formula is right here. And many of you actually remember this from Algebra 1. But m equals y2 minus y1 over x2 minus x1. Remember, the subscripts just mean first and second. First and second. So I have 3 examples of how to do the slope formula. So again, for my first one, I'm given a graph, so I can do rise over run because I have a graph. So 1, 2, 3, 1, 2, 3, 4, 3 over 4. So my m is 3 over 4. For a table, I can just figure out what is the difference from this. So these are my x's. So my x's are going up 4 each time. And my y's, you'll notice, are going up 2. So what I do is I say, okay, they match up perfectly. I do 2 over 4, which is 1/2. For my third one, this is where my slope formula comes in. So this is x1, y1, x2, y2. I plug it into my formula, y2 minus y1 over x2 minus x1, which is 6 minus -2 over 7 minus 5. I get 8 over 2 because the double negatives turn to a positive, and my m is 4. So when I'm doing these, I choose between if I'm doing a graph, table, or 2 points, and I can plug it in from there. The next few pages are practice on this, and in here on the top ones, you're just filling in the numbers and following the flowchart. Please complete the practice and come in with any questions. Thank you.